Welcome to another video for class 12 students. In this video, we're going to discuss the sample paper for the year 2025-26, only the 1 mark part of it. We'll get started. Look at this question. Identify the function shown in the graph. The best way to solve this question is to go by the options. I'm going to take a point which is exactly between 0 and 1. So at this point, x is equal to half, and the corresponding graph has a y value of pi by 2. So I'm going to see which of these options satisfies this x equal to half and y is equal to pi by 2. So first option, sine inverse of 1 by 2, is that equal to pi by 2? No, because it's going to be 30 degrees or pi by 6. So option 1 is incorrect. So second option, sine inverse of 2x, which is sine inverse of 2 times of 1 by 2. So that's sine inverse of 1. So that will be equal to pi by 2. So the answer is correct. So we have a correct option in option B. There is an alternate question for visually challenged people, so I'm posting it here. Inverse trigonometric function whose domain is minus 1 by 3, comma, plus 1 by 3. So again, we're going to take this question from the options. So option A, that's not, so x belongs to minus 1 comma plus 1, so the domain is not going to be minus 1 comma minus 1 by 3 comma plus 1 by 3, so option A is incorrect. For option B, cos inverse of x by 3, so if it is cos inverse of x, then x belongs to minus 1 comma plus 1. If it is x by 3, in that case x by 3 belongs to minus 1 comma plus 1. So x belongs to minus 3 comma plus 3. So we need minus 1 by 3 comma plus 1 by 3. So option B is not also the correct answer. Cos inverse of 3x. So cos inverse of 3x. Here 3x belongs to minus 1 comma plus 1. So x belongs to minus 1 by 3 comma plus 1 by 3 under closed interval brackets. So we have a matching domain. So option C would be the correct answer. We'll move on to the next question. For three matrices, A is equal to, B is equal to, and C is equal to, the orders are given. The order of the matrix A is m cross 4. The order of the matrix B is n cross 3. The order of matrix C is p cross q. The products AB, AC are defined. Okay. So if the product AB is defined, we know that. So the number of columns, the number of columns of A is equal to the number of rows of B, which means A is m cross 4 and B is n cross 3, which means we can find out that n is equal to 4. N is equal to, or rather 4 is equal to n. Okay. So we can rule out some options. N is equal to 3, that's incorrect. N is equal to 3 is incorrect. So next is AC is also defined. So A is m cross 4. C is p cross q. So we can also find that 4 is equal to p. So any option that says otherwise, so we have p is equal to 4 and p is equal to 4. There is no such option where p is not equal to 4. So we have A and B still eligible to be the correct options. We'll have to dig further. And square matrices of same order. So AB and AC are both defined. Okay, so AB becomes a square matrix and AC also becomes a square matrix of same order. Now AB would be the order of AB would be M cross 3. Okay, and here it is said that the order of AB is the same as the order of AC. So we are going to only compare this M cross 3 with, so I'm going to write it this way. So order of AB is same as order of AC. So AC has an order of M cross Q. So from this we can narrow down that Q is equal to 3. Is there a matching option which says Q is equal to 3? Yeah, so Q is equal to 3. So which means these two are also square matrices. So we can find that M cross 3 is a square matrix. So M has to be equal to 3. So M is 3, Q is 3, and P is 4, and N is 4. So the matching option would be option A, where M and Q are 3, N and P are 4. Option A is the correct answer. Question number 3. If the matrix is skew symmetric. So what do we know about skew symmetric matrices? A12 and A21, they are numerically equal, but they have different signs. So which means we can say that R is equal to -3. Likewise, A13 and A31, they are numerically equal, but their signs are opposite. So which means we can say that Q is equal to minus of -2. So Q is equal to 2. And the leading diagonal of a skew symmetric matrix is all zeros. So P is equal to 0. And we also have A23 and A32, which are numerically equal, but their sign are both different. So we can say that P is equal to +4. So this answer would be Q plus T, the whole divided by P plus R. So the answer would be 6 divided by -3. So the answer is -2. So option A is the correct answer. If A is a square matrix of order 4 and determinant of adjoint of A is 27, then find A into adjoint of A. So we need to know a couple of formulas to solve this question. So A into adjoint of A is given by determinant of A into I, and for this determinant of adjoint of A, there is a formula which is determinant of A, the whole raised to the power of n minus 1. Here n is equal to 4. So determinant of adjoint of A, that is 27, is equal to determinant of A times of, raised to the power of 3. So determinant of A should be equal to 3, which is the cube root of 27, right? So A into adjoint of A would be equal to determinant of A, which is 3 times of I. So the answer should be option C. Find the inverse of the matrix 3, 0, 0, 0, 2, 0, and 0, 0, 5. So to find inverse, we just have to multiply the matrix and its inverse to get I matrix. So I'm going option by option. So 3, 0, 0, 0, 2, 0, 0, 0, 5. I'm going to multiply with each of the options. So 0, 0, 3, 0, 2, 0, 0, 5, 0, 0. So the first element would be 3 into 0, and 0 into 2 is 0. So 0 into, so the very first element fails to be equal to I. So this is based on the matrix property A into A inverse, which is equal to I matrix. For I matrix, the very first element should be 1. A subdivision fails that, the option A fails that. So I'm going with option B. So this would be 1 by 3, 0 and 0, 0, 1 by 2 and 0, and this would be 0, 0 and 5. And 1 by 3 into 3 is 1, 0 into 0, 0 into 0. So this is 1. And the next one would be first row versus second column. So this is all 0, and the next is first row into third column, that is also all zeros. And we need to check, so this is also going to be 0. We need to just check second row versus second column. So 2 into 1 by 2, which is 1, and likewise the remaining elements are all going to be 0. And third row versus third column, so that would be, the problem is here it is 1 by 5. Okay, so third row versus third column, so that would be again 1. So we get A matrix into A inverse matrix, which is equal to I matrix. So the option B is the correct answer. Moving on to the next question. Value of the determinant cos 67. Okay, so cos 67 cos 23 minus sine 67 sine 23. This is of the formula cos A cos B minus sine A sine B. So which is cos of A plus B, which is equal to cos of 67 plus 23. So the answer is cos 90 degrees, which is 0. So option A is the correct answer. Look at the next question. It's a one mark question from the chapter Continuity and Differentiability. And if a function is defined by f of x is equal to so and so, is continuous at x is equal to pi. Because it's a one mark question, I'm cutting short the steps. So at x equal to pi, LHL is equal to RHL. So which means k into pi plus 1 is equal to cos of pi. Cos pi is equal to minus 1. K pi plus 1 is equal to minus 1. So k pi is equal to minus 2. K is equal to minus 2 divided by pi. So the correct answer would be option D. Question number 8. If f of x is equal to x into tan inverse of x, so we can differentiate this using the UV rule. F dash of x is equal to UV dash plus VU dash. Now f dash of 1 is asked, so that would be equal to 1 into 1 divided by 1 plus x square plus tan inverse of 1. The answer would be 1 divided by 1 plus x square plus pi by 4, or rather this has to become 1. So 1 by 2, 1 by 2 plus pi by 4. Do we have a matching option? So option B is the correct answer. Next question. A function is increasing on the interval. So to find the critical points, we need to differentiate it and equate it to 0. So minus 1 minus 4x is equal to 0, and x is equal to minus 1 by 4. So there's only one critical point, and that is minus 1 by 4. And one more thing, this is a parabola. We don't have to make that interval wise increasing and decreasing. We can just observe that it is a quadratic function and it has a negative x square coefficient. If it's a negative x square coefficient, it's going to be a parabola which is inverted downwards. and the critical point is x is equal to minus 1 by 4, which means until minus 1 by 4, that is from minus infinity till minus 1 by 4, the function is increasing, and from minus 1 by 4 till uh, infinity, the function is going to be decreasing. So the given function is increasing on the interval minus infinity to minus 1 by 4, which would be not option A. That's because they have included the closed interval brackets. So we have to take minus infinity comma minus 1 by 4 with open interval brackets on both ends. The matching option would be actually minus infinity comma plus 1 by 4. That is also not correct. Minus 1 by 4 comma infinity is also not correct. So if this question had open interval brackets, this question had open interval brackets, I mean the option A had open interval brackets, the option A would have been the perfect answer. But because of the lack of options, the lack of correct options, I'm going with option A. But there is a fault in option A. It should not have had closed interval brackets. It should have had open interval brackets. This is also not correct. That's because on minus 1 comma minus 1 by 4 comma infinity, this would be decreasing. Minus 1 by 4 comma plus 1 by 4 also it would be decreasing. So option B is also not correct. Option B would be mixed actually. So minus infinity comma plus 1 by 4. So plus 1 by 4 would have been somewhere here, right? So it would have a mix of increasing and decreasing. So it is not completely increasing in the interval. So option A is the closest answer, but it should have had not closed interval brackets, it should have had open interval brackets. Look at this question. The solution of the differential equation represents a family of. Now, to solve this, we need to separate the dx and x terms and dy and y terms. So x dx is equal to minus y dy. Integrate on both sides. If you integrate, this becomes x square by 2 is equal to minus y square by 2 plus c. X square by 2 plus y square by 2 is equal to c, or we can rewrite this as x square plus y square is equal to some constant, which can be expressed as a square term. Okay, because this c is a real term, this c is also expressible as a square term. So x square plus y square is equal to some r square, which is the family of circles. And one more thing, note that the coefficient of x square and the coefficient of y square, they are both 1. If the coefficients of x square term and y square terms, if they are different, then it would have resulted in an ellipse. But in this case, the coefficients of x square and y square, they are both equal. So it results in case of circles. Option C is the correct answer. Question number 11. If f of a plus b minus x is equal to f of x, then x into f of x dx is equal to. To solve this, we're going to use the property, which is this x would be replaced as a plus b minus x into f of a plus b minus x dx, and the limits would be as it is, which is a and b. So this is equal to, this can be replaced as f of x dx, and a plus b, this is I. So integration of a plus b minus x, this is a to b. So this can be written as I is equal to integration of a to b, a plus b into f of x dx minus integration x into f of x dx between the limits a to b. If you observe, this is nothing but the original integration, right? Original I. So this is I, this is minus I rather. So I'm bringing this term to the left hand side. It becomes 2I, which is equal to integration a to b, and I can take this a plus b common outside because it's a constant, f of x dx. So if you observe, I is equal to a plus b, the whole divided by 2, integration a to b f of x dx. So the matching option would be a plus b by 2, a to b, f of x dx. Option D is the correct answer. Moving on to the next question. Question number 12. X cube into sine power 4, all that is given. Okay. So integration, we know, is the reverse of differentiation, which means if you differentiate this term, you're likely to get this term, right? So I'm going to take a sine power 5. I can write this as sine x power 4 the whole power 5 and differentiate it. So a is a constant, I'm giving it outside. So if you differentiate this term, it becomes 5 into sine x power, so it becomes 5 into sine power 4 in sine power 4 x power 4, and the term inside gets differentiated, which is sine of x power 4. So if you differentiate sine of x power 4, it becomes cos of x power 4. On further differentiation of the x power 4 term, it becomes 4x cube. So if you take a into 5 into 4, it becomes 20x cube sine power 4 x power 4 into cos x power 4. Now I'm comparing it against this term, x cube sine power. So there is this a also. So it should have been 20a into all these terms. X cube sine power 4 x power 4 cos x power 4. So you get these terms cancelled. Cos x power 4, cos x power 4, they are getting cancelled. Sine terms get cancelled. X cube terms get cancelled. So you are left with 20a, that is equal to 1. So a is equal to 1 divided by 20. That is the answer here. So a is equal to 1 by 20. That is the equation. A is equal to 1 by 20. Question number 13. A bird flies through a distance in a straight line given by the vector. Okay. A man standing beside a straight metro rail track given by a line equation. This is a line equation. Is observing the bird. Okay. The projected length of its flight on the metro track is. So we can take this vector as a vector. Its flight. Okay. So this is the bird's flight. It means its here refers to the bird's flight. There is this a vector, which is I plus 2j plus k vector. And there is one more. The a vector refers to the bird's vector notation. And the man is standing beside a metro rail track. The track is b vector. And the characteristic of a line equation is given by the parallel vector of the line equation. So here I'm going to take just the parallel component in this line equation. So we need to refine this line equation. So R vector is equal to, I'm going to collect the non-lambda I, J and K parameters, I mean I, J, K components, and the lambda associated I, J, K components. So that would be 3I vector and plus 1J vector. And is there a K vector? There's no K vector. So that would be 0K vector. And lambda is associated with 1I vector plus 2J vector plus 3K vector. So B vector would be equal to I vector plus 2J vector plus 3K vector. The projection of the bird on the track is equal to A dot B cap, which is equal to A vector dot B vector, the whole divided by the magnitude of the B vector. So that would be, we need to take the dot product between A vector and B vector. So that is equal to 1 into 1 plus 2 into 2 plus 3, the whole divided by the square root of 1 square plus 2 square plus 3 square. So the answer would be equal to 8 divided by root over 14. So the answer option C is the correct answer. Moving on to the next question. Distance of the point 3, 4, 5 from the y-axis. So what we can do is we can just take this point as 3, 4, 5 from y-axis. It's going to be like this. So this one is x-axis and this is y-axis and this is z-axis. The point is 3 units along the x-axis, 4 units along the y-axis and 5 units. So this point is 3, 4. This is 3, this is 4 and I'm going to elevate it by 5 units along the z-axis. So it becomes here. So this point is 3, 4, 5. The shortest distance from this point and the y-axis is going to be a perpendicular distance from, so y-axis is just a line, right? So we need to draw like this, and this would be 5 units along the z-axis, and this would be 3 units along the x-axis. So I'm drawing a perpendicular. This is from the y-axis, right? So this is the shortest distance. So this is the hypotenuse. This is the hypotenuse distance between 3 units and 5 units. So that would be square root of 3 square plus 5 square, which is equal to root over 34 units. So option B is the correct answer. Moving on to the next question. A, B, and C are 3 given vectors. 2A dot I into I vector. So that would be equal to 6 I vector. So B dot J, so that would be 1J vector. C dot K, that's 2K vector, the same as, is that equal to A vector? No. Is that equal to B plus C vector? That is also not correct, but that's equal to C vector. So 6I minus J plus 2K. So option D is the correct answer. Question number 16. It's an LPP question. A student of class 12, all that is given, maximize that is given, the constraints are given, the graph is also given. So we need to find the missing constraint in this question. So if you observe, the maximize function is given, subject to the constraints. Okay. Okay, so x is greater than equal to 0, y is greater than equal to 0. These two are non-negative constraints. There is one constraint given, 3x plus 4y. I assume this should be it. So 3x plus 4y is less than equal to 12. And there is one more constraint. So these 2 points are given. So here the x-intercept is equal to 1 and the y-intercept is equal to 2. So I'm plotting the equation of this line. So I'm naming this as AB. So AB line segment should have a line equation of x by 1 plus y by 2 is equal to 1. I'm using the line intercept formula that you studied in class 11. So this should be 2x plus y is equal to 2. And because it does not satisfy the origin test, the origin is not included in the region that is being shaded. So I'm going to write the constraint as 2x plus y. The constraint is nothing but the linear inequality. So 2x plus y is greater than equal to 2. The correct option would be option B. Okay, we'll move to the next question. There is an alternate question given for visually challenged people, and that is if z is equal to ax plus by plus c, where a, b, c are all positive, attains its maximum value at two of the corner points 4, 0 and 0, 3. Okay, okay. These are the options. 4a is equal to 3b, 3a is equal to 4b, and so on. Now, z is equal to ax plus by plus c. I'm going to substitute z 4, 0. So that is equal to 4a plus by. So that would be 0 plus c, 4a plus c, and z of 0, 3, that is equal to 0x plus 3y plus c. So these two are equal, or rather 3b, should have been 3b. So the z achieved at the point 4, 0 is the same as z achieved at 0, 3. These two are equal. So we have 4a plus c, which is equal to 3b plus c. The plus c value and the plus c value, they get cancelled. So 4a is equal to 3b. Option A is the correct answer. Moving on to the 17th question, which is also an LPP question. The feasible region of an LPP problem is bounded, but the objective function attains its maximum or minimum value at more than one point. The graph is given. One of the possible points at which the objective function attains its minimum value is okay. It achieves its minimum value at more than one point. One of the points is 5, 0. The point here is 5, 0. Okay. The one of the other possible points at which, okay. Right. So as we can see, 5 comma 0 is a corner point, and it is present along this boundary line. Okay. If the minimum or the maximum is attainable at more than one point, which means the entire line containing the point will become the possible solution for this question. So which means I'm looking at 5 comma 0, it's part of this boundary line. So which means all the points that lie on this line, they will all satisfy the minimum value for this question. So we need to first find out what is this corner point. This would be 0 comma 15, and this point is 5 comma 0. So 5 comma 0 is a corner point. I'm framing the intercept equation of the line. So x by 5 plus y by 15 is equal to 1. So we have 3x plus y is equal to 15. And I'm going to substitute each of these points and check which of these is satisfying it. So 3 into 2 plus 9 is equal to 15, satisfied. Option A satisfies. The second one does not satisfy. 18 plus 6 is not 15. 12 plus 7 is not 15. 0 plus 0 is not 15. So option A is the correct answer. We'll move on to the next question. There is an alternate question for visually challenged people. So this question goes like this. The graph of the inequality 3x plus 5y is less than 10. It's not the entire xy plane for sure. Open half plane that does not contain the origin. We'll plot this. Three x plus 5y is less than 10. So if x is 0, y becomes 2. If y is 0, x becomes 10 by 3. Then x becomes 10 by 3 and y becomes 2. Here it is not definitely option A. And here the origin test is satisfied because 0 plus 0 is surely less than 10. So the origin test is satisfied, which means we're looking at the region on to the left of the line where origin is contained. Open half plane that does not contain the origin, that's false. Open half plane that contains the origin but not the points of the line, that is true, because it is only less than 10 and it is not less than equal to 10, which means we should not have included the line itself. We should have included the points other than the line, which also contains the origin. So which means we have to take this half plane but not the points on the line 3x plus 5y is equal to 10. So option C is the perfect answer. Half plane that contains origin and the points of the line 3x plus 5y is equal to 10. No, because it's only less than and it's not less than equal to. If it were less than equal to in the question, option D would have been the correct answer. But here option C is the perfect answer. Moving on to question number 18. It's a probability based question. A person observes the first 4 digits of your 6-digit PIN. What is the probability that the person can guess your PIN? So he has already observed the first 4 digits of the 6-digit PIN. What is the probability that the person can guess your PIN? So which means only out of 4, only 2 are to be guessed. And these 2 can be guessed in 10 into 10, so which is These four are already noted. These four are already observed. Only two are left. So there can be there can be a possibility of 100 ways in which the last two digits can be framed. So out of a total sample space of 100, there is only going to be one combination. So there's only going to be one combination of two numbers, and the answer should be equal to 1 over 100. So number of favorable outcomes is just 1, and the total number of outcomes is going to be 100. So probability is 1 by 100. So option B is 1 by 100. That is correct answer. Moving on to assertion reasoning questions. Question number 19. Value of the expression sine inverse of root 3 by 2. So sine inverse of root 3 by 2, that is equal to pi by 3, plus tan inverse of 1, that's pi by 4, minus secant inverse of root 2, that's also pi by 4. So if we add all these, pi by 3 plus pi by 4 minus pi by 4, the answer would be pi by 3. So it is given here as pi by 4. It is incorrect. Assertion is false. So the obvious answer is reason should be true. Assertion is false and reason is true. So the principal value branch of sine inverse of x is minus pi by 2 to plus pi by 2. That's true. That of secant inverse of x is 0 comma pi minus pi by 2. That's also true. So reason is true and assertion is false. The option that says this is option D is the correct answer. Question 20. Given two non-zero vectors A and B, if R vector is a non-zero vector such that R cross, so which means R vector R cross A plus B is 0, which means R vector is parallel to A plus B vector. Here it is said that R vector is perpendicular to A cross B, so R vector dot A cross B vector is 0. So if R vector is parallel to A plus B, R vector is perpendicular to the plane containing A and B. Okay. This may be true or may not be true. Look at the reason here. The vector A plus B, can still be lying on the same plane. It need not be perpendicular. It is not perpendicular to the plane containing A and B. So A vector and B vector, the C vector would be this. This is C vector, which is A plus B. They're all still lying on the same plane. So this reason surely false. A vector plus B vector is perpendicular to the plane containing A and B is false. Assertion is true. So this makes this assertion true. So because reason is false, assertion has to be true. So option C is the correct answer. So with that, we'll wind up this session. We'll meet in another session where we'll discuss some more problems from the sample question paper.